The next question is question number 9. In this question, an amplifier circuit is given and the capacitor CC and CE can be assumed to be short at signal frequency and effect of output resistance R0 can be ignored and CE is disconnected from the circuit. Which one of the following is true? So we have here this CE. So basically in the question it is asked what is the effect of this CE. That is, if the CE is removed, then what will happen to the circuit? So we have two conditions: when the CE is connected, and the other condition is when the CE is disconnected. When the CE is connected, for the small signal analysis, this will be shorted, so emitter resistance will disappear. But when the CE is removed, then the emitter resistance will come into play. So we have two cases, with CE and without CE. So among the options, basically we have to find out what is the impact on the input impedance as well as the voltage gain. So we have to find out what is the input impedance and voltage gain with CE, and then we will find out what is this value without CE. Then we will compare and find out the solution. So if we represent the circuit, small signal equivalent circuit, that is when the CE is present. When the CE is present, RE will be shorted. So in the small signal equivalent circuit, the circuit will be looking like this. During the small signal analysis, all the DC voltage sources will be short circuited. That is, this will be grounded, and all this capacitor value will be acting as short circuited. So all this capacitor will be replaced by short circuit, and the input voltage will be there, Vs value will be there. So RB will be connected like this, and this transistor circuit will be represented by this box. That is, HI is the internal base resistance of the transistor, and this is nothing but the current dependent current source HFE IB. So suppose IS is the current that is flowing here. Hence the input impedance is given by Vs by Is. So Vs is nothing but IB into HI, and this IB is by current division rule we can write in terms of Is. That is Is into RB by RB plus HI. So we can get the expression to be like this. Hence the input impedance can be found out by Vs by Is is the parallel combination of HI and RB. In other way, we can directly see that RB and HI are in parallel. Hence the input impedance will be parallel combination of RB and HI. Next, the output voltage we can write the same current, that is HFE IB, will be directly flowing through RC but in the upward direction. So the output voltage will be negative of HFE IB into RC. Now we have to find out this IB in terms of this Vs. Vs is nothing but the same voltage, that is HI into IB. So we can write IB is equal to Vs by HI. So Vs by HI. Hence we can write the output voltage is equal to minus HFE RC by HI. We will replace this IB. Hence we can write the output voltage minus HFE RC Vs by HI. Hence the voltage gain is minus HFE RC divided by HI. So this is the case when the CE is present. Now let's come to the case when the CE is not present. That is the CE is disconnected. CE is disconnected. In that case, the emitter resistance will come into play. So this RE will be connected across here. Now we will try to find out what is the input impedance and what is the voltage gain. Suppose we will try to find out what is the voltage gain. V0 will remain same here, that is minus HFE IB, that is the current that is flowing through this RC in the upward direction. So V0 is nothing but minus HFE IB into RC. Now we will try to find out what is this IB value in terms of Vs. Vs is nothing but, if we apply the KVL across this load, IB into HI, the current flowing across this RE will be IB plus HFE IB. So 1 plus HFE IB is the current that is flowing through this resistor. So the voltage will be IB into 1 plus HFE into RE. So by simplification we can get the voltage Vs to be HI plus 1 plus HFE whole into RE into IB. So we can get voltage gain V0 by Vs by simply dividing these two. So the voltage gain is coming out to be minus HAP RC divided by HI plus 1 plus HAP whole into RE. Now let us try to find out what is the input impedance. We can write this Vs as IB HI plus HAP IB plus IB, that is the sum of the both the current will be flowing through this RE. Hence it will be looking like this. By simplification we can take IB common. If we apply KCL across this node, then IB current will be equal to IS minus current flowing through this RB is nothing but Vs by RB. So IB equal to IS minus Vs by RB. We will substitute this IB here. After substituting, we will get this expression. Now we will try to find out what is Vs by Is from this. So after simplification, we will get the input impedance to be RB parallel with HI plus 1 plus HAP RE. Hence, if we summarize the thing, that is with CE present and without CE, the input impedance and voltage gain expressions will be as shown here. So if we see the input impedance here, when the CE is present, is the parallel combination of RB and HI, whereas when the CE is withdrawn or the CE is disconnected, it is the parallel combination of RB and HI plus 1 plus HAP RE. This value is very large. As this value is very large, the parallel combination will be more closer towards RB, whereas here it is less than RB. Hence the input impedance is increasing when the emitter bypass capacitance is disconnected. Next is the voltage gain. The voltage gain, if you see here, the denominator is much larger than this case, because here it is HI and here it is increased by 1 plus HAP RE. As the denominator value is very large, so the voltage gain will reduce. So we have the input impedance is increasing and the voltage gain is decreasing when the capacitor CE is disconnected. So if we see among the option, the input impedance RI increases and the magnitude of the voltage gain AB decreases. Hence A is the correct answer. Thank you.